All right, so here on the next page, example 2, kind of looks similar to the first one, but this time it says calculate f prime of 1 for the function f of x equals x squared plus 5x. Again, remember when I say f prime of 1, that means calculate the derivative, right? The derivative. So they want us to find the derivative, but the difference here is they're saying find the derivative at x equals 1. Look at the last one. You see how this one just said differentiate, and we just didn't plug in a number, right? But if I want to find the derivative of this at 1, I would plug in 1 right here and then calculate the whole problem. And that's basically what's happening here is they're asking us to solve for the derivative and then plug in 1. Or we can use a little bit of a difference piece in our formula, right? Our formula said this: f prime of x equals the limit as h approaches 0. Well, x is now going to get replaced with 1, which means anywhere I see an x, I'm going to put 1 instead. And that's how I'm going to solve this problem. So come in here, let's get this set up. So I've got the limit as h approaches 0. Okay, and now I'm going to put f of x plus h, but remember we said we're not going to put x plus h, we're going to put 1 plus h because we're trying to solve when x equals 1. So, there's two x's here, so I'm going to have to plug it into two spots. So x squared becomes 1 plus h squared, okay? And I got plus 5x, so I'm going to put plus 5, and then in parentheses 1 plus h. Do you see how this is the same thing? X squared plus 5x, x squared plus 5x. It looks very different now, but just kind of keep track that you're just plugging in anywhere you see an x, put parentheses and write 1 plus h, or x plus h if it was an x problem. This part, we're going to put minus, and now we know x equals 1, right? So there's no reason to plug this whole equation in as f of x because we're plugging x in as 1. So I actually need to solve real quick. What does f of 1 equal? Well, I have 1 squared plus 5. That would be, what? 1 squared is 1. 1 plus 5 is 6. So I can just plug in minus 6 right there. And then we know on the bottom we just put h. Okay, so again, if you plug in 0, it will give you some sort of indeterminate form. It's just going to happen basically because you got this. We know that if we plug in this here, it turns into 1 squared. If I plug in 0 here, this turns into 1 times 5. And then we just get 6. 6 minus 6 is 0. And then on the bottom, obviously, it's 0. So the whole point of these is that every time you do them, you're going to have to do some sort of manipulation now to make it actually turn into a solvable limit. So for this one, it looks like I just got to do some like multiplication and simplification on top, right? Okay, don't screw this up. Oh my gosh, the number of people that I watch go, oh, this is 1 squared plus h squared. Absolutely not. 1 plus h is the same thing as writing 1 plus h times 1 plus h. I think I said 1 plus h is the same thing. I meant to say 1 plus h squared is the same thing as writing two 1 plus h's. And then you have to do that repeated distribution, right? You have to distribute the 1 and distribute the to the h, and then you got to distribute the h to the 1 and h to the h. So we're going to double distribute here, and I would get 1 times 1 is 1. Well, 1 times h is h, and then h times 1 is also h, so really the middle would become plus 2h. If you need to write that out, feel free to write it out. You got some room up top, you could definitely squeeze that in there. Okay, and then I've got h times h, which is plus h squared. Okay, then I got to distribute the 5 in. So right here I've got 5 multiplied by 1 and 5 multiplied by h. So I get plus 5 plus 5h. And then I still got that minus 6 hanging out at the end. Okay, and then on the bottom I got h. All right, I think I have some like terms I can combine here. So the limit as h approaches 0. Let's see. I'm gonna start with the biggest term. I'm gonna start with my h squared first. So I've got h squared. Just for the sake of making this easier on myself, I'm going to cross things out as I do them, or let's highlight them. That way it doesn't look like I've actually canceled them. Okay, then I've got my h's. So I see 2h and 5h. That'll make 7h. Okay, and then I've got my constants. So 1 plus 5 is 6. 6 minus 6. Oh, that actually makes 0. That cancels out. Okay, so I got then h on the bottom. Okay, and now you can start seeing some things coming together, right? I'm going to jump down here. Let's go the limit as h approaches 0. And on top, I can factor out an h. So h squared becomes h. 7h becomes 7. I put an h in front, and then I still got my h on the bottom. And now I can cancel out this h and this h, which will leave me with, I'm not going to write the last one. You can see it now, right? The limit as h approaches 0 of h plus 7. So I'm going to plug in 0. So I get 0 plus 7, which equals 7. So again, what this means is the slope at that point is 7. So if I were to graph this equation, this polynomial, and draw a tangent line at x equals 1, the slope of that tangent line would be 7. Just to kind of show you real quick an illustration, this is x squared, right? So it would look like this. That means maybe 7's right here, and the slope of this line right here is rise 7, run 1. Kind of the idea we're getting at there. Okay. So that's kind of calculated. Like I said, I'm going to show you a shortcut in the next unit that's going to make those a little bit easier to do and won't be nearly as tedious. So don't stress too much. But what is important is that they like to ask MCQ questions where they write out the formula like it is supposed to be written, like we just did, right? They write out the definition of the limit and say, can you, as the tester, identify what the function is and what x value they're trying to take the derivative of? And that's the important part, which is why we practice doing this. So look at this equation right here. The limit as h approaches 0 of 9 plus h minus 3 over h. So I need to identify two things. I need to first identify what is the equation they're using. And to me, it looks like the equation is this piece right here, right? They plugged in 9 plus h. So this should have been the x. So it looks like my actual function was square root of x. And then I got to pick the x value. And so I think the x value is going to be right here, right? It's x plus h. So my x value is 9. And if you ever want to double check that you did this right, you can plug this in right here. What's the square root of 9? It's 3. Did they put that answer here? Yes, then I definitely did this right. So essentially what this question is asking is they're saying, what is f prime of 9 when f of x equals the square root of x? That's what the question says. So sometimes they'll give you questions like this and say, solve this, and you've got to be able to recognize, oh, this is take the derivative of this and then plug in 9 and get the answer. Okay, let's actually have you pause and try this one. I know this one looks a little bit weird. Know that delta x is the exact same thing as h. It's the exact same thing, right? H is just the change in x. Delta x is the change in x. So treat that exactly like you would treat h, and you'll be able to solve this one. All right. Hopefully you did that. You paused it, you tried it, right? Hopefully it's not horrible. Maybe you're still struggling a little bit, but hopefully it's all going to start coming together and clicking. We'll practice this a couple more times too in class to make sure you really got it. So you can see in this one, this is our answer checker, right? So we're going to ignore that for a second. This is what's important. Did they plug anything in here? No, they definitely didn't, right? So I'm going to call this g of x since I used f of x. Sorry, if you used f of x again, it's fine. I'm going to put 2. Okay, and then you can see right here, this is our x plus h. So that means this just becomes x. So I have plus x cubed. Okay, now it's just a matter of figuring out what I plugged in, and I'm pretty sure that the x I plugged in is this negative 3 right here. Let's double check. So if I do negative 3 to the third power, that is negative 27, and negative 27 plus 2 is negative 25. So I definitely did that right. So the question here was, find g prime of negative 3 when g of x equals 2 plus x cubed. All right, one more. This one looks crazy, looks intimidating. You're right. Oh no, how am I going to solve that? Except look, they used delta x for h again, so we know that's h. And x, well, x is just x this time. They didn't actually plug in a numerical value. And if they don't plug in a numerical value, the equation is written clearly for you right there. The equation is, let's call this h of x. The equation is x cubed minus 5x squared plus 4x minus 7. And they just want us to find h prime of x because there is no actual numerical value that they're plugging in for x in this one. Okay, all right, coming down for number 4, estimating the value of a derivative numerically. So the table below shows the body temperature over time of a polar bear on a very cold Arctic day. So the problem with tables is they're kind of incomplete, right? They don't show us everything we need to know. But we can see that after this is a minute. After 1 minute, the polar bear's temperature drops here. And after 2 minutes, the polar bear's temperature drops to there. My dog is very upset I'm doing math and not playing with him. Okay, and then the temperature, you can see it keeps dropping, right? And they want us to evaluate T prime of 5.5. This is a really popular FRQ question. They love to ask this question. Okay, so you'll notice that I don't know anything about 5.5, nor do I have the ability to do the derivative formula on here, right? So when you have questions like this, all we can do is make an estimate, and we're going to estimate t prime of 5.5 by just doing what you know as the slope formula. You're going to do y2 minus y1 over x2 minus x1 with the two values that are closest to 5.5. So I know 5.5 is right in between here and here, right? So I'm going to start by doing the y's. So on top, I'm going to put y2, which is 90.45, minus y1, which is 90.73. And then on the bottom, I'm going to put x2 minus x1, which is 6 minus 1. Make sure you line everything up, right? Did I line these up correctly? Yes. Did I line these up correctly? Yes. And then also don't forget to mess up the y goes on top and the x goes on the bottom. That's an easy mistake to make. Okay, it does say to be sure to express in correct units. So I'm going to make sure I put the correct units. So the top part is the degrees Fahrenheit, right? Because that's my y value, and big T is degrees Fahrenheit. And then the top part, which is what I put on the bottom here, is minutes. So I'm going to put degrees Fahrenheit per minute. On an FRQ, this is worth 2 points. 2 points right there. You would stop right there. That's all you need to write for your FRQs. This is a really popular FRQ question. Do not simplify it. And I'm going to start expressing that a lot more to you. A lot of students make mistakes in their math right here, and then they don't get their full points, right? Essentially what's going to happen is they're going to give you 1 point for the setup, okay, and 1 point for the correct answer. But the AP raters are trained to know that this is equivalent to your correct answer. So if you don't write the correct answer, they'll just count this as 2 points. I say that because, and I know it's hard, it's a really hard habit to build because you really do like to solve the math questions, right? I know that I struggle sometimes. I'm like, I really need to finish solving. So let's just pretend we did finish solving. If you put this in a calculator, you would have gotten that the answer is negative 0.28 degrees Fahrenheit per minute. But what happens if you accidentally typed it in wrong and you switched these two numbers, or you typed it in then you forgot to write the negative? Well, now you only get 1 point for writing this, and you get 0 points for this, so you only get half credit on this question. Whereas if you just stopped here, the AP reader has to give you both points because it is a correct answer. So I'm going to really stress to you this year, don't simplify your work. Once it is what we call calculator ready, right? I could type this into a calculator. Once it is calculator ready, and you can get your answer just by typing it into a scientific calculator, not a graphing calculator, scientific calculator, then you get full credit. So get in the habit of that. Practice that now so that you don't make silly mistakes and lose points, okay? All right, well, that's where I'm going to stop because actually this is part of the next page. So I'm not going to read this yet. We're going to stop right there and we'll come back to it. All right, I'll see you in the next page. Bye.